Hi everyone! Today we're doing notes for 5.1, Introduction to Random Variables and Probability Distributions. A random variable is a quantitative variable x where the value that x takes on in a given experiment or observation is a chance or random outcome. A discrete random variable can take on only a finite or countable number of values. A continuous random variable can take on any of the countless number of values in a line interval. So for this first practice, it says which of the following random variables are discrete and which are continuous. A, measure the time it takes a student selected at random to register for the fall term. Well, we could measure this in months, in days, in minutes, in milliseconds. So this is continuous because time can take on any value. Count the number of bad checks drawn on upright bank on a day selected at random. Well, if we're counting the number of checks, this can only be a whole number, so it's discrete. I would like you to do C and D, please. Measure the amount of gasoline needed to drive your car 200 miles. This will be continuous. Pick a random sample of 50 registered voters in a district and find the number who voted in the last county election. This one will be discrete. Probability distribution is an assignment of probabilities to each distinct value of a discrete random variable or to each interval of values of a continuous random variable. So features of a probability distribution of a discrete random variable. The probability distribution has a probability assigned to each distinct value of the random variable, and the sum of all the assigned probabilities must be 1. A tool of cryptanalysis, the science of code breaking, is to use relative frequencies of occurrence of letters to break codes. In addition to cryptanalysis, creation of word games also uses the technique. Oxford Dictionaries publishes dictionaries of English vocabulary. They did an analysis of letter frequencies in words listed in the main entries of the Concise Oxford Dictionary, the 11th edition. Suppose Langley took a random sample of 1,000 words occurring in crossword puzzles. The table below shows the relative frequency of letters occurring in the sample. A says use the relative frequencies to compute the omitted probabilities in the table. So we're going to take the frequency and then we're going to divide by this total, 1,000, to get the probability. So for A, this is going to be 0.085. For E, it's going to be 0.112. For I, 0.075. O, 0.072. And U, 0.036. Do the probabilities of all the individual letters add up to 1? This is yes. If a letter is selected at random from a crossword puzzle, what is the probability the letter will be a vowel? Go ahead and answer this, please. If I add these up, I could have A, 0.085, plus E, 0.112, plus I, 0.075, plus O, 0.072, or U, plus 0.036. And this is going to add up to 0.38. The mean and standard deviation of a discrete population probability distribution are found by using these formulas. Mu is equal to the sum of x times p of x. Mu is called the expected value of x, which, if you recall, this also is the mean. Mean and expected value can be used interchangeably. Sigma equals the square root of the sum of x minus mu squared times p of x. Sigma is called the standard deviation of x. X is the value of the random variable, p of x is the probability of that variable, and the sum sigma is taken for all the values of the random variable. Note that mu is the population mean and sigma is the underlying population standard deviation because the sum is taken over all the values of the random variable. All right, here's our next practice. At a carnival, you paid $2 to play a coin flipping game with 3 fair coins. On each coin, one side has the number 0 and the other side has the number 1. You flip the 3 coins at one time and you win $1 for every 1 that appears on top. Are your expected earnings equal to the cost to play? So A says, in this game, the random variable of interest counts the number of ones that show. What's the sample space? So if we're thinking of the number of ones that show, we could have 0, 1, 2, or 3 ones that show. So again, this is the total number of ones. There are 8 equally likely outcomes for throwing 3 coins. Again, it's 3 fair coins here. List all the outcomes. So we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So let's complete the table. My number of ones, and then we have the frequency that it happens. P of x, remember, is the probability, and then our x times P of x. It's going to help us get the expected value. So 0, if I have 0 ones, that happens one time. The frequency is 1. So my probability of x, this is 1 out of the 8. So that's where the 0.125 comes from. To get xp of x, remember we take our 0 times 0.125, which is going to give us 0. If I'm doing 1, 1, I have 1, 2, 3 of these. So my frequency is 3. So my probability is 3/8. My xp of x, x is 1. P of x is 0.375. Multiply that together, we get 0.375. If I have 2 ones, we see this happens 1, 2, 3 times. So my frequency is 3. Probability is again 3/8 or 0.375. So my xp of x, I'm doing 2 times 0.375, which is going to give us 0.75. Our last case is when we have 3 ones. This happens one time. So my probability is 1/8, which is 0.125. xp of x is 3 times 0.125, which is going to give us 0.375. The expected value is the sum, mu is equal to the sum of x times p of x. Sum the appropriate column of the table to find this value. So that's this column of our x p of x. So our mu is equal to the sum of x times p of x. So we have 0 plus 0.375 plus 0.75 plus 0.375. And this is going to give us 1.5. Now remember, this is money, so this represents $1.50. Are your expected earnings less than, equal to, or more than the cost of the game? So if you recall, the cost was $2. So this is less than the cost. So in other words, you expect to lose 50 cents per game. In other words, the carnival makes money. All right. Our practice 4 says, are we influenced to buy a product by an ad we saw on TV? National Infomercial Marketing Association determined the number of times buyers of a product had watched a TV infomercial before purchasing the product. The results are shown here. So we can treat the information shown as an estimate of the probability distribution because the events are mutually exclusive and the sum of the percentages is 100%. We have to find the mean and standard deviation of this distribution. So all of our x's are listed in the table. Let's write our p of x's. So again, this is our x. This represents our p of x. So for 1, we have 0.27. For 2, we have 0.31. Then we have 0.18, 0.09, and 0.15. X times p of x is next. So we're multiplying these two together. So this is going to give us 0.27. We're going to have 0.62. We're going to have 0.54. We're going to have 0.36. And again, as a reminder, we're multiplying the x times the p of x, right? So this is like 5 times 0.15, which gives us 0.75. I'll give you the work for that column. Okay, x minus mu. So now we're going to take each value minus the mean. But we didn't calculate the mean yet. Remember, we have to take the sum of these to get the mean down here, okay? So if I add these up, 0.27, 0.62, 0.54, 0.36, and 0.75, this is going to give us 2.54. So now we can go on to the next column. All right, value minus the mean. So I'm going to do 1 minus 2.54, and that's going to give us negative 1.54. Following the same thing, this is going to give us negative 0.54, then we have 0.46, 1.46, and 2.46. Again, I'll highlight the ones where I showed the work in case if you need to come back to them. Okay, next we're going to take the value minus the mean squared. So I can take any one of these. So I'll take this one in the middle here. This is 0.46. When I square that, it's going to give me 0.2116. Okay, so again, we're taking our previous column, our value minus the mean, and we're squaring it. If I square the rest of these, this one is 2.3716. 0.2916. If I square 1.46, we get 2.1316, and 2.46 squared is 6.0516. Okay, now we have to take our value minus the mean squared, so the column we just did, times our p of x. Okay, so again, I'll do the work in this top column. So we're going to take 2.3716 times our p of x, which is 0.27. And this is going to give us 0.640332. I'll do one more. 0.2916 times our p of x, which is 0.31. And this gives us 0.090396. For the rest going on the table, we get 0.038088, 0.191844, 0.09, oops, I'm sorry. This one is 0.90774. So again, I showed you the work on the top two here for x minus the mean squared times p of x. Okay, so now to get our sigma squared, which if you recall, this is our variance. Sigma is our standard deviation. Mu, remember, is our mean or expected value. All right, so to get our variance, we simply add these down. And so that gives us 1.8684. And then we take the square root, and that gives us 1.37. Now, as you're filling in the chart, I want you to go to at least 4 decimal places for accuracy, okay? Once you finish the chart, for your mean or for your standard deviation here, the hundredths place is okay. Again, in the middle of the chart, go to at least 4 decimal places for accuracy. When you're finding the mean and the standard deviation, then it's okay to just go to the hundredths place. Okay? All right, so what does a discrete probability distribution tell us? A discrete probability distribution tells us the complete sample space on which the distribution is based, the corresponding probability of each event in the sample space. Formulas tell us how to find the expected value mu and the standard deviation sigma of the distribution. So linear functions Let A and B be any constants, and let X be a random variable with mean mu, standard deviation sigma. The linear function L equals A plus BX has a mean. Mu of L is A plus B mu. The variance sigma L squared equals B squared sigma squared. Standard deviation sigma L is square root of B squared sigma squared, which is equal to B times our sigma. Linear combinations of independent random variables, A and B are constants. Let x1, x2 be independent random variables with respective means, mu1, mu2, and variances sigma1, sigma2. The linear combination ax1 plus bx2 has a mean mu of a mu1 plus b mu2. The variance sigma squared of w equals a squared sigma 1 squared plus b squared sigma 2 squared. Standard deviation, you take the square root of that variance. So it says a computer repair shop has two work centers. The first center examines the computer to see what is wrong, and the second center repairs the computer. Let x1 and x2 be random variables representing the lengths of time in minutes to examine a computer x1 and to repair a computer x2. Assume that x1 and x2 are independent random variables. Long-term history has shown the following times. To examine computer x1, the mu or mean is 28.1 minutes and the standard deviation is 8.2. To repair computer 2, x2, mu2 is 90.5 minutes and sigma 2 is 15.2 minutes. Let w equal x1 plus x2 be a random variable representing the total time to examine and repair the computer. We have to find the mean, variance, and standard deviation of w. So our mu of w is going to be equal to, we can simply add these together, right? So we have, this is going to be mu1 plus mu2. So 28.1 plus 90.5, which is 118.6 minutes. To find the variance, our sigma w squared is going to be sigma 1 squared plus sigma 2 squared. So this is 8.2 squared plus 15.2 squared, which is 298.28 minutes squared. And so then when we find the standard deviation, our sigma of w is equal to the square root of 298.28, which will be 17.27 minutes. I want you to try B, please. I want you to find the mean, variance, and standard deviation of this one. Okay, our mu w. You can see our formula, right? It's 1.5 mu1 plus 2.75 mu2. So I have 1.5 times 28.1 plus 2.75 times 90.5, which is going to give us, this is money, so I'm putting a dollar sign, 291.03. Our variance, so we have sigma w squared. We're going to take our 1.5 squared times 8.2 squared plus our 2.75 squared times 15.2 squared, and that's going to give us 1,898.53. Last, we have our sigma w, and so we have to take the square root of this, 1,898.53. It's technically dollars squared. So when we take the square root, it makes a little more sense, and we end up with $43.57. All right. The shop charges a flat rate of $1.50 per minute to examine the computer, and if no repairs are ordered, there's also an additional $50 service charge. Let L equal 1.5 x1 plus 50. Compute the mean, variance, and standard deviation. So this one is linear. It's a little bit different. So our mu L is going to be 1.5 times our mu1 plus 50. So this comes out to give us $92.15. When we do our variance, our sigma L squared, this is going to be equal to 1.5 squared times 8.2 squared. Now remember we talked previously, standard deviation and variance are not affected by adding or subtracting a constant. So we're not adding 50 to this. This is going to be equal to 151.29. And so last when we take the square root, sigma L, square root of 151.29, and this comes out to be $12.30. So again, if you're adding or subtracting a constant, your standard deviation is not affected by this. It's only affected when you multiply. And that's the end for today.